According to the Chatelier's principle, a change in concentration of either ion will shift the equilibrium position. What is meant by this is an equilibrium has a forward and a backward reaction, and this happens simultaneously. But if a change does occur, and especially a change in concentration, it would favor either the forward or the backward reaction. But this does not change the equilibrium constant. A change in concentration never changes the equilibrium constant. If some acid is added, the hydronium concentration will increase and the hydroxide ion concentration will decrease. This is because acids produce hydronium ions in aqueous solution, hence this would increase. As a result, the hydroxide ion concentration will decrease, because we know that the ion product constant is always 1.0 times 10 to the power of minus 14. Now, both ions are present in all aqueous solution systems, so we would always have the hydroxide and the hydronium ions in an aqueous solution. But in acidic solutions, we have a lower concentration of hydroxide ions, and the vice versa for basic solutions, where we have a lower concentration of hydronium ions. The calculation of the hydronium and the hydroxide ion concentrations can be done with our simple equation here. We know that the Kw value from the previous slide is 1.0 times 10 to the power of minus 14 m squared. So to work out either one of these, you can just simply use this value and the given value of either hydroxide or the hydronium. So to work out the hydronium ion concentration, what you would do is you would rearrange this equation. Remember this equation that we used earlier on. So by simply rearranging this equation, we get this. And then you would sub in the value of the Kw and the value you are given of the hydroxide ion concentration to work out the hydronium ion concentration. This will become very useful later in the topic. Or we can work out the hydroxide ion concentration by dividing the Kw value over the hydronium ion concentration. It is also vital to know that the units also correspond to this. The units of Kw is m squared, and the units of any concentration is m. So what happens is this cancels out, so we're only left with an m, and the concentration of hydronium ions would always have a unit of m, and that is the same for the hydroxide ion concentration.